In this video, I'm going to introduce you to how to use the wave equation to solve problems. So this problem asks us if a red laser beam has a wavelength of 200 nanometers and a speed of 3.0 times 10 to the 8th meters per second, what is the frequency of the laser beam? Okay, so before you do anything, you should always collect all the information you can find in the problem. So I want to use the wave equation we learned, which is that the velocity of the wave is equal to frequency times wavelength. So I know that I'm going to need to collect information regarding the velocity of the wave, the frequency of the wave, and the wavelength of the wave. So I know that the speed of this wave is 3.0 times 10 to the 8th meters per second. And I should know this even if the problem doesn't give me this information, because I should remember that all electromagnetic radiation, or EM radiation, V is equal to 3.0 times 10 to the 8th meters per second. So if the problem doesn't give you a velocity and you think you should have a velocity, just remember that all electromagnetic radiation travels with the same speed, which is 3.0 times 10 to the 8th meters per second. Alright, what else does this problem tell us? Well, does it tell us the frequency? No, it tells us to find the frequency. So we don't know that. I'll put some question marks here. And the wavelength, it says, is 200 nanometers. Okay, so first things first, before we get started, we can't do anything until we have the same units. So I have nanometers here for my wavelength, and I have meters for my velocity. So I'm going to need to convert these into common units. So I'm going to change the wavelength into meters. And I'm going to do that really quickly. So if I have 200 nanometers, that means that I have, so if I have 1 meter, that means I have 1 times 10 to the minus 9 nanometers. Okay, so that means I have 200, or I'm sorry, 1 times 10 to the 9 is not minus 9 nanometers, it's just 10 to the 9 nanometers. Okay, so that means I have 200 times 10 to the minus 9 meters. Okay, so my wavelength is equal to 200 times 10 to the minus 9 meters. Okay, so next we're going to use our wave equations, which is V equals frequency times wavelength. And I'm trying to solve for frequency, and so I will divide both sides starting off by wavelength. Wavelength cancels out on this side, and I'm left with frequency by itself. Okay, I know that the velocity that I started with, now I'm just going to do some substitution, is 3.0 times 10 to the 8th meters per second. And my wavelength is 200 times 10 to the minus 9 meters. And so I do a little math, and I get 4.3 times 10 to the 14. And so the units of frequency are per second or hertz. So I'm going to use hertz. So my answer is 4.3 times 10 to the 14 hertz. Okay, that's all there is to it. Thank you.